All right, to do this problem, I think I'm going to do integrating factors. So remember, the idea is we want to find a function mu so that mu x prime is equal to mu x prime plus mu 2x. By the product rule, this thing on the left-hand side is mu prime x plus mu x prime. We set that equal to mu x prime plus mu 2x. Okay, the mu x primes cancel, and then we can divide the x's, they cancel, and what we end up with is mu prime over mu is equal to 2. In other words, log of mu prime is equal to 2. We take the antiderivative of both sides. This tells us that log of mu is equal to 2t plus c, but we just need one integrating factor, so we take the one where c is equal to 0. And so this tells us that the integrating factor, mu of t, is equal to e to the 2t. Okay, so that's the integrating factor. I'm going to erase all of this stuff. The integrating factor is e to the 2t. So I'm going to multiply both sides of the equation by e to the 2t. And remember, the whole point of doing that is that the left-hand side is now the derivative of mu times e to the 2t with respect to t. The left-hand side is the derivative of mu times x with respect to t. Mu is equal to e to the 2t, so this is what we have. And on the right-hand side, when we multiply the right-hand side by e to the 2t, we just get t. And so what this tells us is x e to the 2t is equal to t squared over 2 plus some constant. In other words, x of t is equal to t squared over 2 e to the minus 2t plus c e to the minus 2t. This is the general solution to the non-homogeneous equation. Okay, now to find the particular solution, we use the initial condition x of 1 is equal to 0. So wherever I see an x, I'm going to put a 1. Wherever I see a t, I'm going to put a 0. So this becomes 1 is equal to c. So in other words, the particular solution to the initial value problem that we have is x of t is equal to t squared over 2 e to the minus 2t plus c e to the minus 2t.